Everybody's got their own horizon. Yeah. So we are on the edge of a galaxy's horizon 13.7 billion light years in that direction.
The universe is a huge and wondrous expanse of stars, galaxies, and mysteries that swirl past our everyday dreams. Across this gulf, the light of a galaxy's billions and even tens of billion years ago has traveled to us over those vast cosmic distances spanning a mere blink of an eye compared with their staggeringly immense scales. But even after all we know, there still remains one question: what might be hiding just beyond the observable? Journey to the edge of the observable universe and find out what mysteries await the vast cosmos and the complicated relationship between living things. Only a small portion of this is visible, even with our most advanced telescopes or microscopes, to humanity when we look up at the night sky. This volume, known as the observable universe, is over 93 billion light years wide and fills in the extent where visible light has arrived at Earth since almost time early on, 13.8 billion years prior. As with an observer standing on a beach, staring out toward the ocean, all we can see is restricted to what everyone calls the cosmic horizon, or border at which everything becomes invisible. One perspective has been that the observable universe is a huge cider bubble and we happen to be in it. The bubble that contains all the things we can observe defines how far light has so far been able to reach us since being emitted in some galaxy or star long ago, and back then at just such and such a size. This boundary is referred to as the particle horizon, or cosmic light horizon, and it marks an edge of our observational capabilities back into time and out across space. This limit arises from the universe's beginning and what we have learned about space stretching. The first clue that the universe wasn't static came in 1915 with Albert Einstein's general theory of relativity. Then in 1929, astronomer Edwin Hubble found that galaxies were all moving away from each other, with farther galaxies receding faster. This movement suggested an initial event, now understood as the Big Bang, after which space itself has continued to expand, separating galaxies over billions of years. When we say the universe is expanding, it's important to clarify what this means. While it might seem natural to picture galaxies as if they're hurtling through space from an explosion, it's not the galaxies themselves that are expanding. Instead, it's the vast fabric of space in which they exist that is stretching outward. Imagine dots on an inflating balloon. As the balloon expands, the dots move farther apart, not because they're moving on their own, but because the surface itself is stretching. Similarly, galaxies within the universe are getting more distant due to this cosmic inflation. So, if the observable universe has a horizon, does it mean the universe itself has an edge? The short answer is no, or at least not in any straightforward physical way. If universe itself means everything in existence, then it doesn't have an edge in the traditional sense. Instead, it's possible that the universe is infinite, extending endlessly beyond our observable bubble, or that it curves back on itself like a sphere, creating a higher dimensional loop with no endpoint. In fact, it's theoretically possible to wrap around the universe. If it curves in on itself, then with an unimaginably advanced telescope and enough time, you could see the same galaxies from different directions appearing at opposite sides of the sky. But there's no evidence yet that we're in this kind of closed-loop universe. To picture what lies beyond our observable universe, imagine that the night sky is just the closest frame of a vast film reel. We know more frames exist, beyond the edge, each holding galaxies and stars, possibly even entirely new cosmic structures that we're simply unable to detect because their light hasn't reached us. As galaxies continue to drift beyond our visible horizon, outpacing the speed of light due to accelerated expansion fueled by dark energy, future generations won't be able to see the same observable universe we do today. The cosmic horizon is like a bookmark in the ever-evolving story of the universe, capturing everything that's made it to Earth's view since the dawn of time. Beyond that, the universe continues, vast, largely unseen, and still mysterious. While we can only speculate about the hidden realms lying outside our cosmic bubble, the observable universe still reveals a universe brimming with more galaxies than we could ever observe in a lifetime. Although the observable universe is immense, it likely represents only a small slice of the entire cosmos. According to cosmic inflation theory, the universe may be at least 10 circumflex 23 times larger than what we can see. This suggests that, beyond the 93 billion light years that we observe, an expansive, mysterious frontier lies hidden from view. But what might exist in this unreachable expanse? And how does dark energy, driving the universe's accelerating expansion, affect what we see? One theory suggests that the cosmos extends indefinitely beyond the observable universe in a continuation of the familiar structures we see nearby, galaxies, stars, and planets scattered across vast distances. In an infinite universe, every possible arrangement of matter and every conceivable event could exist somewhere, including versions of each of us living slightly different lives. Strange as it sounds, it's a logical outcome of infinite space. Other theories suggest that what lies beyond the observable universe may be very different. In 2008, scientists observed that galaxy clusters were moving at extraordinary speeds in the same direction, most likely under the influence of immense structures beyond our observable reach. This dark flow could be the gravitational pull from massive unseen bodies outside our universe, or even other universes themselves exerting their influence from across a boundary we can't cross. This theory remains controversial, with some data suggesting that the movements of galaxy clusters might be explainable without invoking unseen forces, which leaves the debate unresolved. There's also the possibility that our universe is just one bubble among countless others in a multiverse. This idea suggests that each universe could exist in its own bubble, possibly with different physical properties and laws. Occasionally, these universes might even interact, sparking big bangs, which in turn create new universes. If the theory of the multiverse is true, then beyond our observable universe could lie entire realms of existence governed by different forces. As we move toward the observable universe's edge, we effectively look back in time, catching glimpses of the cosmos in its formative stages. Far-off galaxies appear as they were billions of years ago, revealing that, in its youth, the universe looked vastly different. Galaxies were smaller, lower in mass, and packed closely together, filled with bright blue stars that burned intensely. Around 3 billion years after the Big Bang, star formation was at its peak, producing new stars and creating active supermassive black holes that emitted vast amounts of energy. But over time, star formation has slowed, and galaxies have grown larger through cosmic mergers, creating the more mature systems we see today. Dark energy, a mysterious force discovered in the 1990s, is the main driver of the universe's accelerated expansion, comprising nearly 70% of the universe's total content. Dark energy opposes gravity, pushing galaxies apart faster and faster. This expansion stretches the limits of our observable universe, causing parts of the cosmos to eventually recede beyond our view forever. Dark energy's influence ensures that what we observe changes over time, creating a moving, cosmic horizon that limits what we'll ever be able to see. It shapes the layout of the universe, but also hides sections of it by pulling them away from us at increasingly rapid speeds. To understand dark energy better, scientists are launching powerful telescopes to create more detailed maps of the cosmos. NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, and the European Space Agency's Euclid mission, launched in 2023, will help astronomers study how dark energy has shaped cosmic structures over time. These observatories, alongside Earth-based efforts like the Vera C. Rubin Observatory, aim to reveal the mysteries of dark energy's behavior and impact on cosmic evolution. As the limits of the observable universe are reached, we are also reaching the inception of time itself. Only observing distant galaxies means that we observe them in their earlier years, when the universe was only a few thousand million years old. Back then, there were no heavy elements and everything was all over, in a blue, violent atmosphere with plenty of stars of that burning hot age. Finally, close to the time of the Big Bang's overview as observers, we reach a final limit of our observation, since many of the physical laws as we know them cease to hold true. Now the question is there a possibility to look further beyond the observable universe? At the moment, we are confined to the most remote light that has managed to reach us, regardless of the evolutionary timescale since the Big Bang. But later advances will be made, and light from more remote galaxies beyond the current cosmic horizon will come into view, complete with the form of the universe. But there is a limit to this. The expansion of the universe is super accelerating in nature, evidenced by dark energy, which limits the amount of what we will ever see. This is not the slowing type of expansion. It is the type of expansion that is so fast that it is so far away puppies even light cannot reach them. While there are still trillions of galaxies that are in transit towards us, there exists a final boundary under which the ultimate limit will be the horizon that will never pierce our sight. Presently, the universe is estimated to be about 13.8 billion years old, and geoscientists can only make observations of regions that are approximately 46 billion light years away. After billions of years, a region of almost about 61 billion light-years will be explored. Thereafter, an unreachable universe will protrude, and as the expansion increases, will vanish more rapidly in the shadows. As we continue our exploration, one question lingers in the cosmic air. What do you think lies beyond the edge of the observable universe waiting to be discovered?